Hello and welcome to a Minitab 17 version of Fun Times and Statistics. Today we're going to be doing some two-sample testing. If you haven't done so, please download the Word document you see on the right and the data that you see on the left into Minitab 17 so you can follow along as I proceed through today's lesson. So the first thing we're going to do is what's called a two-sample t-test. So we're going to check the nearly normal assumption by doing some things. Namely, I'm going to do some histograms and look at our data and see if it looks like it has this condition met. And I'm only checking one condition here. There are other ones you should check, but this is the one we're going to check for this problem. So the first thing I'm going to do is I'm going to go up to, where is it? Graph, histogram, and here she comes. I'm going to hit simple for now. And then I'm going to graph the variable spend lift. And then I'm going to hit the multi-graph button. And this is so I can make separate graphs for each piece of my data. So spend lift has some different behaviors based on its groupings offer and no offer. If you read through this part of the description of the data, you know this already. Good times. I didn't read it this time because, well, this is going to be a long video. And you can pause and read. So I'm going to hit multi-graph. And there's some options on here. It's like, oh, you want to do separate graphs? I'm like, nah, I want to do in separate panels on the same graph so I can set them next to each other. And I like mine to have the same scale and bins so that my number of bins looks the same for both graphs or both groups so I can kind of compare them a little bit immediately. And then I'm going to hit by variables. And then here it's like, oh, you want them in separate panels or you want the variables to group on separate graphs? I'm like, yes, I do. I would like to make separate panels. I'm going to do that by group. And then I'm going to hit OK. And then OK again. Ooh, I don't know why it's taking so long. There we go. So this is what you should get. Sometimes Minitab will color these two differently for fun. I don't know why it does that. And it can be quite different depending on what you're looking at. So just so you're warned, hey, sometimes it will do this. The other thing I wanted you to be aware of is this is not the only way to do this. You can, and I'll show you the second way, but we're looking for, do these look relatively normal? So they look fairly symmetric. No offer looks more symmetric than offer. They both look unimodal. This looks like it kind of falls off the unimodal path. This looks pretty almost bimodal, so that's a little bit of an issue. But other than that, they have at least one characteristic of the normal distribution. So both of my groups appear to be nearly normal. So let me just write that down. Both are fairly symmetric. And unimodal. This is good enough to be nearly normal. The other thing is their spread looks pretty close to a normal. I mean, you know, how it's spread out in kind of a bell shape. Okay. So as I'm looking at this, you might keep in mind that, oh, I might have to do a larger sample just because these aren't perfectly normal looking. They've got some wiggle to them where they have a little bit of skew or bimodality. So you're aware of this fact going into it. So if you're the one selecting the samples from this, you'd pick larger samples because of that. The other thing is, this is not the only assumptions. I said that once before, but you should also be checking, you know, is it independent and not more than 10%? And you don't really do Minitab to do that, but, you know, little note, hey, you should be checking independence and less than 10% of the population as well. So just keep those in mind. So here's the other way you can produce that graph. I should also copy this graph over. And how I do that is I right click in the gray space and you'll see the option to copy graph. And I'm just going to set that right in here. And just leave her right there. I am zoomed in a little bit, so this is going to get awkward how it adjusts it, but it's good enough for now. Okay. So the other way you can acquire this graph is a little bit more complicated. I'm just going to close that since I don't really need it. You can go up to graph. We're still doing a histogram, but instead of choosing simple, you can choose with groups and hit OK. And I still want to do spend lift because that's my quantitative variable. And then it asks you, hey, what's your categorical variables for grouping? And I'm like, oh, group. Hence its name. Fun times, right? So the next thing you want to do is you want to make sure that it knows how you want to group this. So we also hit the multigraph button. And then here you want to tell it how you want to do this. You can overlay on the same graph. If you do this, it will color code and lay them on top of each other. I actually don't like how this looks. It's kind of complicated looking. Actually, let me show you that just in case you do like it. So we're going to leave this as is for now and hit OK. We're just going to go through this twice. Boy, she's running slow today. So I don't like this because I think it's a little hard to read, but this is just an opinion, not a fact. Maybe it's very clear to you that, oh, pink looks pretty much spread the same as what you see over here. And then the blue graph behind there, the only thing I want you to be careful about is some people, when they see the purple bars like this, they'll think, oh, well, this is part of the red and the blue, so they think this is a stacked graph. Be careful, this is not a stacked graph. It's like one laying in front of the other, like they're made out of cellophane or something see-through. So I don't like this graph as much, but again, opinion. So let me show you the other one. So same steps as before. I'm still just pulling up histograms with groups. I hit multigraph, and then you tell it to put it into panels. And then I'm going to choose the same X's as before. I'm going to hit by variables and tell it to separate it by group. So a lot of the end steps are the same. It's just you select by group at the beginning. So it's really, stuff. I don't know why I'm bothering with this. Cool, but here you get different colors. So if that really super matters to you, that's how it's done. Enjoy. Okay. It's a little silly. Now, let's go ahead and do our two-sample t-test. So, when it comes to the two-sample test, my null is always the same thing, and that's that I think the mean of these two groups is the same. So I'm going to write that as, mu for mean, which is the name of the symbol that we've been using for mean, little fancy m. It's also pronounced mew if you like cat noises instead of cow noises. So I think the mean for offer, if you don't like this, seriously, you can just write mean offer there. That's probably a good solution that everybody will enjoy. Is equal to mean underscore no offer. So this underscore is just me keeping track of my two groups. My mean for, on average, my offer group is the same as my average for my no offer group. That's what this is really saying. That's my null hypothesis. I think these two groups are the same, or that there is no difference between my offers and how people are going to behave in their spending. Okay. So, as we look at this, you might want to think about, oh, well, what's my alternative going to be? And if you go back and read through this, they're like, oh, they just want to know if these are different and stuff. So my alternative is that they are not equal. So I'm just going to copy this down below, and I'm already out of space. Let's insert my not equal to symbol. And symbols, not equal. So there we go. Oh no. I think they're the same. I think there might be a difference between these two groups, and so I want to see if the offer encouraged spending or not. So now we are going to perform the test. Woohoo! So we're going to go up to Stat, Basic Statistics, and over to the two-sample T. So I'm looking at a quantitative variable, spend lift, and it's being organized or separated into the two groups by this categorical variable, offer, no offer. So every individual has two characteristics we're keeping track of: what their spending was, and then whether or not they had received that offer. So we actually have all of our samples in one column, organized or identified by this other column. So spend lift is our samples, IDs is our group. Then, as always with any type of testing, we want to hit our options and make sure it's set up the way we want. So as you look at this, it's doing sample 1, whatever that happens to be, minus sample 2 is going to be the difference I look at. The hypothesized difference is 0, so I think there is no difference between them. And it's a not equal to. This is a 95% confidence interval. We're not really doing a confidence interval here. We're doing a hypothesis test, but it's still going to produce one anyway, because you will get an entire confidence interval every time you choose a not equal to, like always. Let's go ahead and hit OK, and then hit OK again. Oh my. I'm wondering why it's producing something so large this time. I should fix that. It's like zoomed in on me. Woohoo! Okay. Let's copy this over. Okay. Couple things worth noting. Now, perform the test. There's my test results right here in Word. So as you're looking at this, there's a few things worth noting. 10 minutes of me messing with my pen. Okay, so it tells you what your offers look like as you're looking at this. Notice it uses the mean that you might expect it to. Oh my God. Okay, so notice it tells you how it's calculating the mean. Okay, so notice it tells you how it's calculating the mean here, offer minus no offer, so that you're aware where that difference is being calculated from, and you know what the order of the groups is in, because remember, we were putting in our directions for Minitab to calculate this. It was just sample mean 1 minus sample mean 2, so now it's specifying, oh, I'm doing no offer minus offer. So looking up above, I have offer first, so I sort of subtracted offer over to the other side. And this is important to keep in mind when we're doing our estimating. So, a couple other things to notice is that their standard deviations are pretty close, so it wouldn't have been a horrible idea for you to try something different with this. It also gives you SE of the mean. Remember, this is the standard error of the mean. This is the sampling distribution contributions that each of these have. Other things that's important for you is the average estimate for the difference. This is the mean of one group minus the mean of the other. That's all it is. That's how that's calculated. And it's not as rounded as the mean reported up above. Other things to note, hey, there's the confidence interval for the difference. Woohoo! Notice it's completely negative, which means you know that when I look at offer minus no offer, this is negative more often than not, or 95% of the time. The average of the difference will be negative, which means your offer group had to have been larger, so you're seeing more spending in the offer group. Okay, other things to note. Hey, it gives me my p-value. Woohoo! It's super tiny. We shouldn't find that too shocking. Sorry. All right. So P is super tiny. We shouldn't find that too shocking because we were kind of seeing that there's a huge difference between them anyway up above. The last thing you should note is there's your degrees of freedom. Notice that it calculated it for you. Remember how I told you the formula for that and I showed it to you in the lesson was super, super gnarly? There you go. There's how you calculate it. Okay. Let's state our conclusion for all the world to see. Why do I suddenly randomly get accents? That's super weird. Anyway, so the p-value is indicating for you, hey, it looks like there is a difference. Now, this doesn't tell you which one's bigger or smaller. The confidence interval points you towards that. But what you should say is that was my bird, there is strong evidence, real confident this time, strong evidence, that there is a difference in average spending depending on the offer that is received. AKA getting an offer made a difference, and I'm actually going to say with a p-value of 0.001. Super tiny. Yep. Okay. So I'm going to do this again. So if you're looking at number 2, I'm done with number 1. I'm going to repeat this experiment, this exact same question, but I'm going to do some different things. In particular, I am going to do this with a pool. So I'm going to assume equal variance, and I'm going to check that box to make it pool. The other thing I'm going to do is I'm going to calculate a 97% confidence interval for the difference. So I'm going to scroll back up because my null and my alternative haven't changed. I just want to know, is there a difference here? So I'm going to cheat and just copy and paste that. Woohoo! Oh, why does it always want a number? I don't want numbers. I talk too much. Let me tab this over. Why am I organizing my words? It's fine. There's some time I waste in these videos. Okay, so the next thing I'm going to do is I'm going to perform the test, and I really just want you to see the slight difference in results here. And it's so slight. So we're going to go up to Stat, Basic Statistics, still 2 sample T, so nothing new yet. Here's the one place where we're going to have some differences. We're going to go to our options, and then I want to change this to a 97%er. That way I have the one for part B. And then the last thing I want to do is I want to check this box that says assume equal variance. And that's how you make it pool. That's it. Just check that box. Make it equal variance. Yep. And that's not a too unreasonable assumption because our samples were pretty close in standard deviation, but that doesn't mean that that's necessarily true that they are exactly the same. We're going to make that assumption and see what happens. Okay, I'm gonna copy my results over. Okay, and do a little bit of adjusting so that it's all on one page. And then I want a different color highlighter. Okay. So we are a poolin'. Wow. Okay. So the weird thing about this, or maybe the not so weird thing, is that this doesn't change that many things. What should you notice? Well, my p-value came out exactly the same. My t-value came out exactly the same. My degrees of freedom is different, and it used a pooled standard deviation. So this was the standard deviation it was using, not these two in combination with each other and using the sum. It was using this one. So when that was done for this example, some things did change. So my degrees of freedom did change. The other thing that changes, notice that my well, that's probably different just because it's, you know, a 97% or not a 95%er. So there's that. But still completely negative, still super tiny p, still super tiny t. So as we go forth into this, I'm hoping you notice that, you know, pooling doesn't usually change that much. So if you're ever worried that you accidentally pooled when you shouldn't have, usually there's not that big of a difference. And besides that, you can always rerun the test anyway to see if there is a difference. So if you ever question this in the real world, it doesn't hurt you to run 2 tests. Unless it costs you a ton of money, which I don't think it should, honestly. So our results didn't change anything. In fact, if you want, we can be super lazy and just go up here and grab this same guy and do circus music for no reason. And there you go. It's always with the numbers. Still the same result. Occasionally there will be a difference, but more often than not, there is not, especially if your standard deviations are super close together. All right. Let's look at that 95% confidence interval. This is the more interesting observation here. So what we want to say is, oh, well, what's the confidence interval? Well, it's negative 200.9, comma, negative 38.9. That's it. Yep. And now I'm going to describe this. There's a couple things I want you to notice. It's completely negative and there's no zero. So what this really tells you is that overall, people in the offer group are, you know, spending negative dollars on average than the no offer group. Or, wait, no, not negative dollars. People in the offer group are spending on average this amounts more than the offer group. Here, let me write this. Me doing it verbally never goes that well. So we are 95% confident. Come on. That the offer group spends between $200.90 and $38.90 more on average than the no offer group. So clearly the offer is making people spend more on average. So we should do the offer. It's a good time. It's giving us some monies. We're getting more sales and more business from it. It's a good time. Okay. Let's look at doing some paired data. So if you're interested in doing paired data physically, as in like given some data, hey, let's do this, I have an example doing that on your lessons area. So it's in the chapter 13 folder. But for today, I am going to do one with summarized data because I haven't done that for number 3. So just so you can see a summarized one, here it is randomly at the end of the paired, pooled, and unpooled instructions. So here we go. So we need we need to read through the question, which I'm assuming you can pause and read now while I set up some null and alternatives. Woohoo! Okay. So we think that there is no difference is our alternative because it's always the status quo of no, I don't think anything changed. And that would be that my mean difference is 0. We use D for difference. And then our null, or sorry, alternative, we just did the null, hello, is going to be that I think the difference is different. So I think it's not 0. So let me insert my symbology. Boo, boo, boo. 0. Gotta click over here after you do that to make it come back. Fun facts. Okay, so now that I've got my null and my alternative set up, there's my summarized data up above. Let's go ahead and enter in our summarized information. So one of the things you should have noticed when you're reading this through is that I only gave you the information about the difference because that's all you need to do a paired test. You don't actually need like the group A, group B, or the before and after. You just need how different was it, and then the statistics on the difference. So we're going to go up to stat, basic statistics, down to the paired. And then instead of samples and columns, I need summarized data for differences. So my sample size here was at 10. My sample mean, where's my mean? Is 1.02. Oops, that's a comma. And then my standard deviation is that 1.196. Alrighty, and then I should be good to go, but I should always check my options with any type of testing. 95%, not equal to, I think the difference is 0. We're good. Notice it's noting to you, oh, I'm doing the difference mean of sample 1 minus sample 2, not mean 1 minus sample mean. Not mean 1 minus mean 2. It's the mean of sample 1 minus sample 2. So I'm doing the subtraction first and then doing the mean, not doing the means and then subtracting. There's a big difference there. You know what I mean? We hit OK. We hit OK. Alrighty. So paired. Let's copy our output over. Well, that was a mistake. Remove enumeration. Okay, so I'm going to hit enter here just to make my p-value show up in one line. So they give you a confidence interval for the mean difference. They tell you the t-test for the mean difference. They tell you what the t-value is. They tell you what the p-value is. And then they give you this data you put in already. The only thing new up here is that they give you the standard deviation for the sampling distribution, aka the standard error of the mean. So reject, I think there is a difference. So, you know, the difference is not 0. There's something going on here with these values. So I would say that the evidence suggests that there is a difference in sweetness measured after the tasting. Woohoo! With a p-value of 0.025, and we're good scientists, so we report the p-value. All right, so that's how you do a summarized data paired test. The one I did in the previous examples didn't use summarized data, so I wanted to make sure that you understood how to do it using the summary instead of just using the individual values. And